If I want to insert, already I am having value 40 there, then here it is not possible to insert directly. If I want to perform insertion operation, then how to write the algorithm? Now I am going to explain. For example, A is the array with n elements. Here, if I have equals operator, it means that the values will move from right side to left side. For example, there is a difference between A equals B and A double equals to B. Welcome back to one and all. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysuru. Today, we will start with the fourth session of Data Structure chapter. Whereas already in the previous session, you come to know regarding searching an element, that means how to find the location of an element, under that linear search as well as binary search. Linear search is nothing but searching an element one by one from the beginning till the end, whereas binary search means here we are searching an element in the method of dividing the entire array elements into two parts and then comparing the search element with the middle element. Then algorithm for linear search as well as algorithm for binary search. Whereas in today's class, you will come to know insertion of an element as well as algorithm for insertion, with that deleting an element from the array as well as algorithm for deletion. Whereas usually you will get the algorithm for 5 marks in the final exam. Whereas in the previous session you have studied regarding the linear search algorithm as well as binary search algorithm. How to perform binary search, regarding that already you came to know. Whereas now insertion of an element. What do you mean by insertion of an element? Inserting an element in a given array. Here consider we have the array elements position wise 0, 1, 2, 3. Here A, B, C, D. Here our agenda is to insert an element. If I want to insert an element in a particular position, then how the element can be inserted? For example, here in this array, you have the elements A, B, C, D on the position 0, 1, 2, 3. If I want to insert at the position 1, how to insert? Here already I am having value. Then how to perform that? That you will come to know today. Arrays insertion refers to inserting an element. Inserting an element in the array. When the element to be inserted into a particular position, all the elements from the asked position to the last element should be shifted into the higher order position. Whatever element we have, all the elements we have to shift from the position to right hand side. That means here for right side, for higher order position, we have to shift all the elements. For example, consider the array 10, 30, 40 and then 60. These are the array elements. Now, how to perform insertion? Consider, suppose if you want to insert an item 50 has to be inserted at the position 2. Consider this is the array element. On that array, I want to insert a new item 50 at the position 2. Then how to perform? Already you know that the array elements 10, 30, 40 and then 60. Position wise 0, 1, 2, 3. For example, here you want to insert an item 50 in the position 2. Here in the question itself, for example, the position if you are going to get 2, then here you have to observe in the array 0, 1, 2. On this particular place, we want to insert the new item, call it as 50 here. If I want to insert, already I am having value 40 there, then here it is not possible to insert directly. Then shifting process has to be taken place. How to shift? Which element we have to shift? While shifting, we have to shift the element from the last position to higher order position. See, in the first phase, we have shifted the last element, that is n minus 1 element, from third position to fourth position. That is our first phase. That means we are shifting all the elements till we will get the position. Now this space is free now, because in the beginning, if I want to insert an element 50 at the position 2, it is not possible because already I am having value. Now we have to shift all the values from that position 2 till the last position to higher order position. Now here the position wise is 3, but now we are shifted at the position 4 in the first iteration. But when they come on second phase, here what we have done, whatever element here, the 40 here, that we have shifted here. In the position 2, whichever element we have, that we have shifted to the next higher order position, that is 3. Once the place is free, because we want to insert an element 50 at the position 2. Now this position is free now. Then afterwards, insert the new item, whichever item you want. Now insert that item to that particular position. See, if you observe here, we are shifted all the elements one by one from the last position to higher order position until we will get the position. Once we reach the position, new item has to be inserted to that position. Once if I inserted an item, then obviously array size increases, because in the beginning 1, 2, 3, 4 elements we have. After inserting one element, on the place of 4, now we have 5 elements. Their position wise 0, 1, 2, 3, 4. Now is it clear? In the beginning, the last element position is 3, but now the last element position is 4. It means that now we are inserted the element 50 successfully in the position 2. It means that if I want to insert any element, then first thing, the process here will start from the last element to the position where we want to insert. Till that, shifting has to be taken place to the higher order position. See, I am going to explain with one more example problem. Consider we have the array elements A, B, C and then D. Position wise 0, 1, 2, 3. In the first step, here you have to mention from where to where we have to shift. Before mentioning all the steps, you have to mention which are the variables we are using. See, algorithm for insertion. If I want to perform insertion operation, then how to write the algorithm? Now I am going to explain. For example, A is the array with n elements. A is the array of n elements and item is the element to be inserted in the position P. It means that we are using the position P, array name A and n is the number of elements and item is the element to be inserted. Now in step 1, here if you observe, only 4 steps are there. This 4th step itself carries 5 marks in the annual exam, because it's a usual question in the exam you may want to get, that is, write the algorithm to perform insertion of an array, or how to insert an element in the array, write on the algorithm. Like that, you may want to get the question. See, first step, in step 1, we have to mention for I equals n minus 1 down to position. We are not increasing here. If you observe the previous problem, first we have shifted the third element to the fourth position, then second element to the third position. It means that we are decreasing the values. First 3, then 2 and then 1 and then 0. Like that we are shifting. That's why here we have to mention for I equals n minus 1 represent the last position. Here compulsory have to mention down to position. First we have considered 3, then 2 and then 1. That's why we use write down to position. Here what we have done, here exactly for I equals n minus 1, now I represent the last position 3. What we have to do now, here if you observe here, a of I value will move to a of I plus 1. In the first phase, what we are doing? We are shifted A, B, then C. Now whatever value in the D, that we are shifted to the next position. 0, 1, 2, 3, 4. That is the step here written. A of I represent the last one, n minus 1. That n minus 1 we are shifted to a higher order position. That is A of I plus 1. To that place we are shifted. Like this, the process will continue again and again until we are going to get the position. That means consider I want to insert one more element, call it as M in the position. This is the item I want to insert at the position, for example 1. First step, the last element we are shifted to higher order position. Then next step, now the position is 3. Now once again shifting will take place because we want to insert at the position 1. Then the next phase A, B, here the C will shift to higher order position. C and then D. Position wise 0, 1, 2, 3, 4. Still I get position 2. But how long I have to process? Until I am going to get a particular position where I want to insert. Then once again whatever value here, that here it will shift. Then the value become here A. Then here the value is shifted B, C and then D. Position wise 0, 1, 2, 3, 4. Now I get the place where I want to insert. It means that the for loop will start from last position till the position where I want to insert. That means here shifting are taking place until I will get a particular position. This for loop will again and again, it will execute until we get the position. Once if I get the position, new item will be shifted to that particular position. Here in this case, M is a new item, that here will shift here. Once if I shifted, then what about the array size? In the previous case, the array size, the last element itself, it is on the position 3. But now the last element position is 4. That's why n equals n plus 1, then exit. Here, if you have the equals operator, it means that the values will move from right side to left side. For example, there is a difference between A equals B and A double equals to B. Here, this can be called as assignment operator. See here the value of B will move to A. Whatever value in the right side, that will move to left side if you have assignment operator. If you have relational operator, if you have 2 times equal symbol, then it can be called as relational operators. Here, there is no any movement will occur. It says that right hand side value is same as left hand side value. Whereas here what happens? The new item will be inserted to A of position. Whichever position we are given in the question, for that position, new item will be inserted. Then array size increases, then exit. This 4 steps itself carries 5 marks in the annual exam. It's very, very important. Next, we'll discuss about regarding deletion an element or deleting an element from the array. How to delete an element? In the insertion case, I told you which is the element I want to insert, that also we have to mention. On which position we want to insert, that also we have to mention. See here first you have to mention which is the item I want to insert, on which position I want to insert. Both the things you have to mention. Whereas under deletion, no need to mention which is the item. Only if you mention the position, that is enough here. Once if I deleted an element, then obviously array size decreases here. Whereas deleting of an element means here refers to removing an element from the array in a particular position. Already I told you whichever position we want, on that position we can able to delete the item. Here no need to mention on which is the element. Which is the element, no need to mention. Only thing you have to mention the position. After deleting an array element from the array, all subsequent elements from the array shifted to lower order position. Consider we have the array elements like A, here B, and then C and then D. Position wise 0, 1, 2, 3. For example, if I am going to mention the position 1, on this position whatever element we have, that item we can able to remove directly. Only thing you have to mention the position, which position I want to delete. Then afterwards all the elements will shifted from this higher order to lower order. Then first A here, then afterwards C will shifted here, then next iteration D will shift here. Then obviously the array size here decreases. Consider an array, example 10, 30, 40, 60. These are the array elements. Under that, suppose I want to delete an element 30 at the position 1. It means that if you observe here, then on this position I want to delete 30. Now consider how to perform the problems. Consider we have the array elements 10, 30, 40 and then 60. I want to delete the element at the position 1. For example, if you want to delete, first step, whatever elements, this is the array 0, 1, 2 and then 3. On the position 1, whichever item we have, that we will move to the temporary place, call it as item. Then afterwards, in the first phase, now once we are deleted, that space become empty here. Once if I delete it, now that space is empty. Then what is the next thing you can able to perform? Whatever element in the next adjacent position, in higher order position, that we have to shift here. Then in the second phase, here we have 40, that we are shifted here. Whatever thing here we have, that we are shifted here. Now this space become free. Once that space is free, then the next adjacent value we have to shift here. Then we are getting 10, 40 and then 60. If you observe here, in the previous case, the last element position is 3, but now here, the last element position, that is n-1, is 2 here. It means that the array size here decreases. When you delete an element, obviously the array size decreases. If you are inserting an element, then obviously the array size increases. While deleting an element from the array, there must and should, first thing you have to delete the element, then later on whatever element in the adjacent position, all the elements we have to shift to the lower order position in each and every phase. Now is it clear? Now we will explain this with an algorithm as well as one problem. This is also very important. In the exam, you will going to get the question, write an algorithm to delete an element in an array. Then first thing you have to mention which are the variables we are using here. While writing, A is the array with n elements, item is the element to be deleted in the position P. It means that here the name of the array is A and n is the array elements and item is the element to be deleted in the position P. Then how to perform this? Already I told you in the example. See, consider we have the array elements A, B, C and then D. Position wise 0, 1, 2, 3. Step 1. Remove the item. For example, I am going to give the position equals, for example, 0. Consider here in this example I given the position is 0. First step 1. Whatever value in the position that we have to move to item. Here I given the position is 0. Then on this position, this is the element A of I that we have to move to a temporary place. That is the first step here that I will move to item. Then now what is the array elements here? B, C and then D. Position wise 0, 1, 2, 3. First step, we have moved whatever element in that position to item. Then afterwards, shifting has to take place. While shifting, we have to mention I equals position to n-1. On whichever place, this is a position, the 0 represents a position. From that place till the last element. From the place where I deleted, from that place till the last position, for I equals position to n-1. from that position to n minus 1. Whatever I represent the position. For example, here in this case, position represent 0. Now what we have to do? 0 plus 1. A of 0 plus 1 we have to move to A of I. Then here whatever element position, this represents position plus 1. That is, this is I plus 1. Then in the next phase what we will do? We will shift this B to the first place B. Then this place is free C and then D. 0, 1, 2, 3. Like this, the process will repeat again and again till the last element. Now we shifted this one. Next phase will shift this element to the lower order position. Now the elements become B, then C. Now we'll free this space and then D. 0, 1, 2, 3. The next phase, here we'll move this D value here. Now the value become B, C, D. Position wise 0, 1, 2, 3. It means that the process will continue till the last element. Now is it clear? Once if I shifted all the elements from higher order to lower order position, what about the n size? Now if you observe here, we have the extra space. That space we have to remove. Then in the final thing, you are going to get B, C, D. That is 0, 1, 2. That means array size now we are decreasing. That is n equals n minus 1. It means that in insert an element, especially under insert an element, array size increases in the beginning 3, now it is 4. But in the case of deleting an element, the array size decreases once we have deleted the element. Now is it clear for all of you? It means that here the loop will again and again it will execute until we have to get the last element. Then afterwards, once we have deleted all the elements, then finally we are going to remove that element. Now is it clear for all of you? Then next class you will come to know regarding two-dimensional array. Before that you will come to know regarding what do you mean by sorting, different types of sorting techniques like bubble sort, selection sort, insertion sort. Whereas in your syllabus you have insertion sort, then how to perform insertion sort, how to do the problems on insertion sort, as well as algorithm on insertion sort. Regarding that, next class you will come to know. Thank you for all of you.